At sample test paper 2, the first question that we didn't get a chance to look at during our review session was question 5. And 5A states, list 2 characteristics of a homologous series. And there's a few things that you could have written down here. You have to have at least 2. But one of them would be that they differ by a CH2. One carbon and 2 hydrogens. Another thing that you could potentially put down here is that they're going to have similar chemical properties. That's because all of the molecular shape and all of the different things that are attached to it, the alcohol groups, the aldehyde groups, all of that would be the same and give those same chemical properties. The only thing is that we're making it a longer chain by adding another CH2. Third thing that you could put is that it's going to have gradual changes in physical properties. For instance, if we make just an alkane, and the longer we make that alkane by just adding more CH2s and CH2s, there's going to be more places for van der Waals forces. So as we're increasing those van der Waals forces, more force would be required to overcome the intermolecular forces and for it to go from a liquid to a gas, so boiling it, just again due to the fact that it's bigger and it's got more internal molecular forces. 5B says that ethanol and ethanoic acid can be distinguished by their melting points. And it says state and explain which of the 2 compounds will have the higher melting point. So the first thing you want to make sure to say is which one will have a higher melting point. And that's going to be the ethanoic acid. Again, it's going to be important to make sure to clearly address all parts of the question. So that first statement, say, yes, this is the one that's going to have a higher melting point. And then go into the why, because that's the second part of the question. And that's due to the higher intermolecular forces, stronger intermolecular forces in ethanoic acid than the ethanol, and that's because there are 2 hydrogen bonding locations as opposed to just 1. And again, that's the intermolecular forces, so we have an attraction between all of the ethanoic acids because there's a strong force between the oxygen and the hydrogen within the molecule, so the intramolecular bond. Part C says to draw 3 isomers of C4H9OH. So we know we're going to have a nice long chain of 4 carbons. And we can place, let's just get all of them here, C, 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 and C, 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 with another C coming down here. So I've got my base chains there. I could have an OH group on the second carbon in, and that would be the same as if I put it right there, because that's the second carbon in. I count from wherever my functional group is. So here it's 1, 2. If it was here, it would be 1, 2. I could also put it right on the end. And then if I have this structure, I could put it right here. And then I don't want to forget all of my hydrogens that are around. So each carbon must have 4 bonds for it to be satisfied. Each hydrogen must have 1, and each oxygen must have 2. And when I have it set up this way, I meet all of those requirements. And for the sake of time, I'm not going to write in all these extra hydrogens, but we know that there are hydrogens on the rest of these carbons. So those are 3 isomers that contain that alcohol group. And that is it for question 5.